Jerry likes to play with numbers. One day he wrote all the integers from 1 to 2024 on the whiteboard. Then he repeatedly chose 4 numbers on the whiteboard, erased them, and replaced them by either their sum or their product. For example, Jerry's first step might have been to erase 1, 2, 3, and 5, and then either write 11, their sum, or 30, their product, on the whiteboard. After repeatedly performing this operation, Jerry noticed that all the remaining numbers on the whiteboard were odd. What is the maximum possible number of integers on the whiteboard at that time? So for this problem, there are a few different observations to make, and these observations, we usually call them invariants. The idea is that there are certain quantities that are going to remain consistent throughout this entire process, and that consistency is what we call an invariant. So the first invariant, which we'll pose as a claim, is that the number of numbers on the whiteboard on the whiteboard is always congruent to 2 modulo 3. And so why is this? Because there are originally 2024 numbers on the whiteboard. 2024 is congruent to 2 modulo 3. And after every operation, Jerry is taking 4 numbers and replacing them with 1 number. So on every step, the number of numbers decreases by 3. So therefore, this proves that the number of numbers will always remain 2 modulo 3. Now, if we look at the answer choices, you see that only 1010 and 1013 are going to be congruent to 2 modulo 3. This means that the number of integers on the whiteboard at any time cannot be B, C, or E. So now we're left with A and D. Now we're going to show that D is impossible. This is going to imply that the answer is A. The idea here is that there are 1012 even numbers. So our second claim will be that the answer is going to be 1010. So we're going to use the fact that there are 1012 even numbers on the whiteboard. And so on each operation, Jerry cannot choose 4 even numbers because, well, he could, but the problem is that the sum or the product is going to be even regardless. So ideally, we want Jerry to either choose 3 even numbers and 1 odd number, or he could choose 4 even numbers. And so in either case, the number of even numbers on the whiteboard is always going to decrease by 3 if he sticks with either of these 2 strategies. So 1012 divided by 3, this is equal to 337 and 1/3. What this means is that Jerry cannot get all of the integers odd after exactly 337 steps, because 1012 is more than 3 times 337. This means that Jerry needs to perform this operation at least 338 times. I'll leave it as an exercise to show that it is possible to have all of the integers remaining odd after 338 operations. Now, after each operation, the number of numbers decreases by 3 as before. So this means that the greatest possible number of integers is going to be 2024 minus 3 times 338. This will be 1010, which is A.